Now then to something which is a little less fact-prone. These are some climate predictions, climate model predictions, and what I'm going to show you is 3 sets of figures, and you can pay some attention to the year which is stated above, but obviously since this is predictions about the future, it's highly uncertain. So whether this is the exact conditions in 2015 or whether this is what we will see in 2020 or 2025 is certainly is less certain, but this is the development that we predict based on the best knowledge that we have today. What you see on the left is the winter situation, and what you see on the right is the minimum summer situation. And here, as predicted for 2015. And you see that in the winter there's ice in all of the Arctic. There's ice in Baffin Bay. There's ice on the east coast of Greenland. So basically there's ice everywhere. The white line is where ice used to be in the period 79 to 2005. So most of the area where we used to have ice in the last 25 years, we still have ice, or we'll still have ice in 2015. In the summer, however, the situation here predicted for 2015 actually looks pretty much like the situation we've seen this year and last year and 2007. So this is not that far from what we've already observed, a strong reduction in the ice cover compared with where the white line is, where the ice used to be in summer 20 years ago. Moving another 20 years into the future, you still see that the ice, it's thinner, the ice in the winter, but we still have ice in the entire Arctic Ocean during the winter. The summer ice on the right is even more reduced. Again, I stress that this says 2035, but since these are predictions for the future, they are uncertain. So this is the trend that we expect we will see, but the actual years you should not pay that much attention to. This can happen sooner or later, but with the global warming that we are seeing, this is the trend in the ice cover that we will expect. Thinner ice in the winter and less ice, much less ice in the summer. The remaining ice in the summer, also notice, is in the Canadian archipelago, the area north of Greenland, or between Greenland and the North Pole, and north of the Canadian archipelago. That's where we already in the past have had the thickest ice, and therefore that's also the area where the ice will survive the longest. It's worth noticing also that ice in the Arctic, a lot of it, as you've already heard, is formed in the past during the winter. So that's now more than 2/3 of the ice. The remaining ice typically can survive up to 5, 6, 7 years. So within a period of 10 years, we no longer have any of the ice that we had 10 years ago. It's all something that's formed during the past years. So it's not so that, or it's different from the inland ice, for example, or the ice sheets, where the ice remains and we have basically the same ice for thousands of years. In the ocean, the ice is replaced all the time, and the main mechanisms for that in the Arctic Ocean is export of ice in the strait between Spitsbergen and Greenland, down along the east coast of Greenland, where the ice eventually melts, and then that ice, in a budget kind of way, is replaced by this new ice that's formed on the Siberian shelves in particular, and the area in the Beaufort Sea north of Alaska. So there's this continuous wheel of exporting ice through Fram Strait down along the east coast of Greenland and replacing that by some new ice that forms over the Siberian shelves every winter. Since the ice is getting thinner, what we can expect is also that what we call the store ice or the multi-year ice on the east coast of Greenland, we will see much less of that in the future. Eventually, the ice in the Arctic gets much thinner, and therefore this 3, 4, 5 meter thick ice that we've seen drifting down the east coast of Greenland we can expect that to disappear, or at least to be much more seldom. Finally, 2055, some 45 years from now, you see again a further thinning of the ice, so the colors reflect the thickness of the ice. There's no longer any of the yellow and red colors in the winter. We see ice in the winter, it's north of Greenland again and north of Canada, up to in the order of 3 meters thickness, where in the present or near present climate we've had ice in that area of 5 or 6 meters or even more. So a further thinning of the ice is expected, and also here in 2055, most of the ice in the Arctic may be gone, but looking that far into the future also is even more uncertain. So So whether this situation will occur in 2055 or whether it will occur in 2075 or even later than that is very difficult to predict. A number of different scientific institutions have attempted to predict it, though, and this slide shows attempts to reproduce the past climate. So the timeline at the bottom runs from 1900 to 2100. All the different colored curves that wiggles up and down and develops along this timeline are various climate model predictions of the development of the ice cover in the Arctic at the summer minimum. The red curve is the actual observations of ice cover in the Arctic. We have reliable observations since sometime in the 1950s and up until the present time. And what you can see is that the minimum ice cover that we've seen in the last couple of years, the strong dip of the red curve at the end there, is actually, it happens before any of the climate models predict that it should happen. Some of the climate models, there's a French model and an American model, the yellow and the blue ones, they predict similar developments, but only in the year 2030 to 2040. Whether what we are seeing in the observations is the same as the climate models predict should happen 20 years from now is still debatable, but at least some of the climate models have similar developments. What we can then also learn from that or think about from that is that once the climate models have shown these rapid decreases in ice cover, none of them really recovers. They may recover for a couple of years, and you may see more ice in a couple of years after a strong drop in ice concentration or ice extent. But after that, the general trend of reduction in the ice cover continues. So again, that's what the climate model predictions tell us will happen. The timing is uncertain, but the general development is what all climate models show. A few words then in addition to that. As you all know, the Arctic winter is dark and cold. You saw in the climate model predictions that there's still ice in the winter. There will be ice in all the Arctic Ocean in the winter, at least the next 50 years and probably longer into the future as well. Right now, we have, or for the last 50 years, we have average temperatures for the larger, major part of the Arctic Ocean of minus 30 degrees during many months of the winter. And if climate change even increases that by 10 degrees in the Arctic, that's still going to be minus 20, which is cold, and it's still going to be dark, so there's no solar radiation during the winter. So the Arctic Ocean will continue to freeze up during the winter. This is true also for most of the marginal seas, including an area like the Baffin Bay. Actually, the expectations, if we look at Greenland, would be that the Baffin Bay would have similar development or similar ice cover as we see today, probably with a longer period, ice-free period during the summer, but with approximately the same area of ice extent during the winter. There's a lot of interannual variability in Baffin Bay and Davis Strait, the West Greenland area, and that will probably remain so. On the East Greenland, in the East Greenland area, on the other hand, I already alluded to this multi-ice, the thick ice coming from the Arctic, that will be reduced in the future. So that may actually change the general ice conditions on the east coast of Greenland. But on the west coast, it will probably be a slower progression because the west ice, as we call it, the ice on the west coast of Greenland, will continue to grow during the winter and will continue to be there for many years into the future.